Welcome to lecture series EPG Padasala for Computer Science. In this lecture, we will be discussing object oriented metrics. Learning objectives: describe the characteristics of object oriented software engineering metrics, outline the metrics which are used for analyzing the software quality, outline the desirable values of factors which affect the quality of software. Introduction: metrics is used to mean a set of specific measurements taken on a particular item or process. Software engineering metrics are units of measurements that are used to characterize software engineering products, software engineering processes, and software engineering people. Software engineering metrics. Software engineering metrics is used to quantitatively define success and failure for a product, process, or person. Identify and quantify improvement, lack of improvement, make meaningful and useful managerial and technical decisions, identify trends, make quantified and meaningful estimates. Characteristics of object oriented software engineering metrics. First, let me give you an introduction towards object orientation. What is an object? An object is an entity of interest with well defined attributes and exhibits behavior. Behavior is through operations that are performed on an object. State of an object: set of values associated with each attribute of an object at a point of time. Objects that share common properties are grouped into a class or object class. Diagrammatically, a class is represented as a rectangle with 3 compartments. The first compartment denotes the class name, second compartment the list of attributes. Associated with each attribute there will be an access specifier. Examples of access specifiers include private, public, protected. The third compartment the list of operations. An operation can be a query operation or an update operation. A query operation will not alter the state of an object. Example: balance inquiry you perform on an account. An update operation will alter the state of an object. Deposit money in your account, withdraw money from an account. For a given problem, when an object oriented methodology is adapted, objects of interest will be identified. Once the objects of interest are identified, association among the objects are identified. For example, employee works for department. Employee is an object, department is another object. Works for is an association between employee and department. When you are identifying an association, appropriate multiplicity has to be identified. One employee works for one department, a department can have many employees working in it. So, the multiplicity is many to 1. Similarly, hierarchies can be identified. Employee can be specialized into full time employee, part time employee. When a generalization specialization hierarchy is identified, class, subclass relationships are identified. A subclass is identified only if the subclass has attributes specific to it. To be brief, in object oriented modeling, the modeler identifies objects of interest, their attributes, and the relationship among the objects. The analysis model developed will be translated into a design model, the design model will be translated into code. In today's lecture, we will be mainly focusing on object oriented software engineering metrics. Object oriented software engineering metrics are different because of localization, encapsulation, information hiding, inheritance, and object abstraction techniques. Localization. Localization is the process of placing items in close physical proximity to each other. Functional decomposition processes localize information around functions. Data driven approaches localize information around data. Object oriented approaches localize information around objects. Conventional software versus object oriented software. Conventional software localization is based on functionality. A great deal of metrics gathering has traditionally focused largely on functions and functionality. Units of software were functional in nature, thus metrics focusing on component interrelationships emphasized functional interrelationships. In object oriented software, localization is based on objects. Instead of functionality provided by an object, at least some of the metrics identification must recognize the object as the basic unit of software. Within system of objects, the localization between functionality and objects is not a one-to-one relationship. Encapsulation. Encapsulation is the packaging or binding together of a collection of items. Low level examples of encapsulation include records, arrays, and subprograms. Objects encapsulate knowledge of state, whether statically maintained, calculated upon demand, or otherwise. Advertised capabilities and the corresponding algorithms used to accomplish these capabilities. Encapsulation has two major impacts on metrics. The basic unit will no longer be the subprogram, but rather the object. We will have to modify our thinking on characterizing and estimating systems. Two encapsulation measures in metrics suite are attribute hiding factor and method hiding factor. First, let us discuss attribute hiding factor. The attribute hiding factor measures the invisibilities of attributes in classes. The invisibility of an attribute is the percentage of the total classes from which the attribute is not visible. Method hiding factor. The method hiding factor measures the invisibilities of methods in classes. The invisibility of a method is the percentage of the total classes from which the method is not visible. Information hiding. Information hiding is the suppression or hiding of details. The general idea is that we show only that information which is necessary to accomplish our immediate goals. There are degrees of information hiding ranging from partially restricted visibility to total invisibility. Encapsulation and information hiding are not the same thing. Example, an item can be encapsulated but may still be totally visible. Information hiding plays a direct role in such metrics as object coupling and the degree of information hiding. Inheritance. Inheritance is a mechanism where one object occurs characteristics from one or more other objects. This is also termed as generalization, specialization, hierarchy. A superclass is identified and the superclass can have subclasses. To be more clear, generalization, specialization can be viewed as a superclass, subclass, hierarchy. A subclass is identified only if there are attributes specific to it. All common attributes are modeled in the superclass. As an example, let me consider a company hires 3 different types of employees. 1, regular, 2, consultant, 3, daily wages. The attributes of regular employee include employee number, name, date of birth, gender, date of joining, designation, basic pay and PAN. The attributes of consultant include employee number, name, date of birth, gender, date of joining, designation and consultancy charges. The attributes of daily wages include employee number, name, date of birth, gender, date of joining, designation and wages per day. An employee who belongs to the company may be either a regular employee, consultant or daily wages. I said generalization, specialization is a superclass, subclass, hierarchy. All common attributes are modeled on the superclass. A subclass is identified only if the subclass has attribute specific to it. Attributes that are common to regular employee, consultant and daily wages include employee number, name, date of birth, gender, date of joining and designation. So, I can model a superclass employee with the attributes employee number, name, date of birth, gender, date of joining and designation. Attributes specific to regular employee are basic pay and PAN. Attribute specific to consultant is consultancy charges. Attribute specific to daily wages is wages per day. So, I can specialize the employee class into 3 subclasses: employee subclass, consultant subclass and daily wages subclass. The regular subclass will have attribute basic and PAN specific to it. The consultant subclass will have attribute consultancy charges specific to it and the daily wages subclass will have attribute wages per day specific to it. Let me give you one more example. A company hires 3 types of vehicles: 1, truck, 2, car, 3, motorbike. The attributes of truck are registration number, chassis number, engine capacity and maximum load. The attributes of car are registration number, chassis number, engine capacity and number of passengers. The attributes of motorbike are registration number, chassis number and engine capacity. The attributes common in all these 3 types of vehicles are registration number, chassis number and engine capacity. So, I will be modeling a superclass vehicle with attributes registration number, chassis number and engine capacity. I will specialize vehicle into car and truck. Car with attribute number of passengers, truck with attribute maximum load. I will not have a subclass for motorbike because motorbike does not have attribute specific to it. So, one important point is when you are identifying a generalization specialization hierarchy, it is a superclass subclass relationship. All common attributes are modeled in the superclass. A subclass is identified only if it has attribute specific to it. So, inheritance in a mechanism where one object occurs characteristics from one or more other objects. Single inheritance, an object may occur characteristics directly from only one other object. Multiple inheritance, an object may occur characteristics directly from two or more different objects. Of course, there are other types of inheritance also, multi-level inheritance, hybrid inheritance. Inheritance decreases complexity by reducing the number of operations and operators. The two metrics used to measure the amount of inheritance are the depth and breadth of the inheritance hierarchy. Depth of inheritance tree, number of children. Depth of inheritance tree. The depth of a class within the inheritance hierarchy is defined as the maximum length from the class node to the root or parent of the class hierarchy tree and is measured by the number of ancestor classes. The deeper the class is within the hierarchy, the greater the number of methods it is likely to inherit, making it more complex to predict its behavior and therefore more fault prone. Deeper trees require greater design complexity since more methods and classes are involved. Interface changes within the tree must be reflected throughout the entire class tree and object instances. The deeper a particular tree is in a class, the greater potential reuse of inherited methods. Number of children. This metric is the number of direct descendants, subclasses for each class. Classes with large number of children are considered to be difficult to modify and usually require more testing because of the effects on changes on all the children. A class with numerous children may have to provide services in a large number of contexts and therefore must be more flexible. Abstraction. Abstraction is a mechanism for focusing on the essential details of a concept while ignoring the inessential details. When moved to higher levels of abstraction, we ignore more and more details. That is, we provide a more general view of a concept or item. As we move to lower levels of abstraction, we introduce more details. That is, we provide a more specific view of a concept or item. There are three commonly views on the definition for class. A class is a pattern, template or a blueprint for a category of structurally identical items. The items created using the classes are called instances. A class is a thing that consists of both a pattern and a mechanism for creating items based on that pattern. A class is the set of items created using a specific pattern. That is, the class is the set of all instances of the pattern. However, in most of the object oriented literature, we define object as an entity of interest with well defined attributes. An attribute is nothing but property of an entity. Object is an entity of interest with well defined attributes and exhibit behavior. Behavior is through the operations that are performed on the objects. Some literatures define object as an instance of a class. While developing a model using object oriented methodology, we identify objects of interest, group objects that share common properties into a class and then identify the relationship among the objects. Meta class versus parameterized class. A meta class is a class whose instances are themselves classes. A meta class is an abstraction of its instances. A parameterized class is a class in which some or all of the elements may be parameterized. New classes may be generated by instantiating a parameterized class with its required parameters. Meta classes usually have runtime behavior, whereas parameterized classes usually do not have runtime behavior. Metrics for analysis: coupling, cohesion, complexity, weighted methods per class, additional measures, number of classes, lines of code. Coupling is a measure of interdependence of two objects. The coupling factor is evaluated as a fraction. The numerator represents the number of non-inheritance couplings and the denominator is the maximum number of couplings in a system. The stronger the coupling between software artifacts, the more difficult it is to understand individual artifacts and hence to correctly maintain or enhance them. The larger the sensitivity of unexpected change and defect propagation effect across objects. Consequently, the more testing required to achieve satisfactory reliability levels. So, to brief this, the stronger the coupling between software artifacts, one, more difficult to understand individual artifacts and hence to correctly maintain or enhance them. 2, the larger the sensitivity of unexpected change and defect propagation effect across artifacts, which is nothing but ripple effects. Cohesion refers to how closely the operations in a class are related to each other. Cohesion of a class is the degree to which the local methods are related to the local instance variables in the class. High cohesion indicates good class subdivision. Lack of cohesion or low cohesion increases complexity, thereby increasing the likelihood of errors. Complexity: weighted methods per class. Weighted methods per class measures the complexity of an individual class. A class with more member functions than its peers is considered to be more complex and therefore more error prone. The larger the number of methods in a class, the greater the potential impact on children. Classes with large numbers of methods are likely to move application specific, limiting the probability of reuse. Additional measures: number of classes. If a comparison is made between projects with identical functionality, those projects with more classes are better abstracted. Lines of code: if a comparison is made between projects with identical functionality, those projects with fewer lines of code has superior design and requires less maintenance. Summary of metrics: metric, desirable value; coupling factor, lower; lack of cohesion of methods, lower; cyclomatic complexity, lower; attribute hiding factor, higher; method hiding factor, higher; depth of inheritance tree, low; number of children, low; weighted methods per class, low; number of classes, higher; lines of code, lower. Summary: a software metric is a standard measure of a degree to which software system or process possesses some property. The availability of the software metric helps the project manager to control the various activities of the development life cycle and contributes to the overall objective of software quality. As objects, or the fundamental building blocks for the object oriented programming rather than algorithm. The approach of software engineering metrics for the object oriented environment should be different from the functional programming environment. Different software engineering metrics for the object oriented development environment have been discussed here. I acknowledge the authors of the books which I have referred and the web resources I have used for this presentation. Thank you.